Question 22, we have three circles overlapping, each of them with a radius of 8 centimeters. So that distance there is 8. This distance here is 8. We're trying to find the area of the two shaded segments. I can also draw into this point up here and have that as 8 centimeters. Now, I also know from that point to the center to the point B is also 8 centimeters, alright, which means we have an equilateral triangle. So this is 60 degrees. I can do the same thing over here, 8 and 8. So we have 60 degrees. 60 degrees here as well, and here. But at the center we have this straight line, so this angle here is also 60 degrees. Lots of angles of 60 degrees in here. Because this is 60 degrees and 8 and 8, this is an isosceles triangle, the base angles must be the same, so they're also 60 degrees. So we have another equilateral triangle at the top. So if I think about this shape we have at the top, it's made up of this right here, where the straight lines from A to B to C, if I would, well, I won't call them A, B and C because we have that in the question, but if we have the point X to the point Y to the point Z in straight lines, we've got an equilateral triangle. I also know that that shaded area there is the same as this here. It's just the arc of the circle made around the equilateral triangle, because the equilateral triangle here is exactly the same as the equilateral triangle up here. So those two areas cancel each other out. But we have another arc of a circle here. So if we can find the area of the equilateral triangle, and the area of that section of the arc, we can find the shaded area. Because the shaded area is made up of the equilateral triangle, subtract 2 of those arcs and add 1 of them. So overall, subtract 1 arc. So if I can have the area of the equilateral triangle, subtract the area of the arc, I should get the area, the shaded area up here, and then double it for the other shaded area. Okay. So the area of the equilateral triangle, because we know 8, 8, and 60, the area of this triangle, we can just use the area sign rule, which is half times 8 times 8 times sine 60. Sine 60 is one of those exact values of trigonometry that you should know. Half of 8 is 4, so 4 times 8 is 32, so this is the same as 32. Sine 60 is root 3 over 2. So overall this is 16 root 3. So we've got the area of the equilateral triangle, 16 root 3. The area of the part of the circle up here, the segment of the circle up there, we need to find the area of the sector of the circle first, because if we can find the area of the sector of the circle, and which is this whole shape here, and then subtract the area of the equilateral triangle, we've got that little bit left. So the area of the sector is going to be, well, first of all, we've got a 60-degree angle here, so this is 1/6 of a full turn, so what we've got is 1/6 of a circle. So 1/6 of pi r squared. The radius is, sorry, not 4. The radius is 8, so it's 1/6 pi times 8 squared. That's the area of the sector of the circle. Now 8 squared is 64, so we have 64 over 6 pi. So the tiny area at the top here, we'll call that, well, it doesn't matter what we call it, the area of the tiny part up there is going to be that 64 over 6 pi, subtract the area of the triangle, which was 16 root 3. 64 over 6 pi, that simplifies to 32 over 3 pi. So we'll leave it as that for now. Now the overall shaded area then is going to be the area, 2 lots of the area, 2 lots of the area of the triangle, 16 root 3, subtract the area of, subtract the tiny area that we just figured out, subtract the tiny area, which is 32 over 3 pi, subtract 16 root 3. Okay. Now inside here we have negative root 32 over 3 pi, and we have negative times negative 16 root 3. So altogether this is 2 lots of 16 root 3, subtract 32 over 3 pi, add 16 root 3. Because subtracting a negative is the same as adding. Which is 2 lots of 16 root 3 is 32 root 3. 2 lots of negative 32 over 3 pi, which is negative 64 over 3 pi. And 2 lots of 16 root 3 is add 32 root 3. Tidy that up a bit, got 32 root 3's plus another 32 root 3's, which is 64 root 3. And taking away 64 over 3 pi. And that's how many centimeters squared you get. Right, you get 1 mark for the angle of 60 degrees or an angle of 120 degrees, depending on the method which you use. Alright, you can get 1 mark for identifying the area of the equilateral triangle. 1 mark for correctly getting the area of the sector of the circle. 1 mark for correctly identifying a full method for calculating the area of the grey sectors, and then 1 for correctly getting to the right answer.